This is numbers 1 through 6 on the study guide. When we factor, you always start with the GCF. So we're going to start with that on number 1. And I notice that this does have a GCF. What can we divide out both terms? Well, they both have an x, and the smallest exponent is 2, which means that that's the most we can take out. So x squared times what gives me x to the 4th? Well, how many x's are we missing? We're missing 2. 2 plus 2 is 4. Then we have plus, and then there's no number here, so x squared times what gives me 4x squared? X squared times 4. Now we want to look at what's left inside here. See, I see 2 squares, but this is not a difference, a subtraction of the 2 squares, which means there is nothing left that I can do. This would be my final answer. Now let's look at number 2. Again, first thing we always start with is the GCF, and I notice that every one of these terms has an x, so we're going to pull it out. So x times x squared plus 6x minus 27 is going to give me that GCF when I pull it out. And now notice I see a trinomial on the inside. When you see that trinomial, you can go to that factor x here. So we want to think what two numbers multiply together to give me negative 27, but add together to give me 6. And if I think about that, 9 times negative 3 is negative 27. 9 plus negative 3 is 6. So we bring down our GCF, and then we get our 9 here with an x, so x plus 9. And then we've got this x minus 3, and then that would be our final answer. Now, if you look at this next one, we don't have a GCF here, but we've got 2 terms, and I see a subtraction sign. So we should say, are these both perfect squares? Which they are. So this is a difference of 2 squares. So we open up 2 parentheses. What times itself is x squared? That would be an x. What times itself is 169? That would be 13. And then 1 would be plus, 1 would be minus. So that would make the middle term disappear. So that's your final answer. On this next problem, I do not see a GCF that I can pull out here. However, I see 1, 2, 3, 4 terms, which means I'm going to have to factor by grouping. So I'm going to group the first 2 terms together, x cubed plus 3x squared. And then we always put an addition sign right after that parentheses, always, because that negative is going to go inside the next set with that 4x. So now we're going to take our GCF here. They both have an x. The smallest exponent is a 2, which means that's the most I can take out. And so x squared times x gives me x cubed. X squared times 3 gives me 3x squared. The GCF here, notice there's a negative in this front term, which means we need to pull it out. And so the GCF for both of these would be 4. So negative 4 times x gives me negative 4x. And negative 4 times positive 3 gives me negative 12. So now here I've got the x plus 3 is something that they both have, so I know this is factorable. And then I have x squared minus 4, but you have to be really careful before you box this as your final answer, because this is a difference of 2 squares. You always want to check that. So we bring down the x plus 3, and now we need to go ahead and factor this next piece here. So x times itself is x squared, 2 times itself is 4, and one of these would be plus, one of these would be minus to make sure that that middle term went away. And that would be my final answer here. Now in this next problem, we see that we have a difference of 2 squares again, so we want to open up 2 parentheses. So we have x times x, and it's actually going to be x squared times x squared is x to the 4th. And then we have 9 times 9 is 81. One of these will be plus, one of these be minus. Which again, you have to be careful because I see a difference of 2 squares, which means we should keep going. So we bring down the x squared plus 9, and then we open up 2 sets of parentheses for this one. X times itself is x squared. 3 times itself is 9. We have one that's going to be a plus, one that's going to be a minus. Now we're back to odd exponents, so we know that this cannot factor any farther. That's it. On this next one here, you'll notice that I don't even see that we have a GCF. Can't take it out. But it is a trinomial, so we should go ahead and work with our factor x. Since the leading coefficient is not 1, we want to multiply a times c. So 2 times 20 is 40. and then we have 13 that would go here. So two numbers that multiply together to give me 40, add together to give me 13 would be 8 and 5. So we bring down the 2x squared plus 8x plus 5x plus 20. So now notice these two would add up to be 13x, but I'm splitting them so that now I can factor by grouping. Here's my first group and here's my second group. The GCF that I can take out of here would be 2x, and then I would have 2x times x is 2x squared, plus 2x times 4 gives me 8x. The GCF out of this one would be 5, so 5 times x gives me 5x, and 5 times positive 4 would give me that 20. So we write our final answer. We have x plus 4 here, and then we take the two GCFs on the outside. They combine to give me the last factor here, and now we just box this and we're done.